Alright, welcome astronomy students to your first lesson here on astronomy units. Units 1.1 through 1.3, those are basically the same as my physics videos, so if you wanted to check those out, go back through your metric review, metric to English conversions, and scientific notation. Please check those out on my physics page. But for 1.4, let's go right into astronomy units. So I have given you a decent sized list here of some astronomy units. So we have our astronomical unit, known as an AU. This is the average distance from the Earth to the Sun. You have to have the average and not an exact distance, because at different points in our orbit, we are closer or farther away from the Sun. Now, keep in mind that our orbit is elliptical, and that is the reason for those differences in distance. We have a parsec, fun term here. We have mass of the Earth. We have a solar day, known as a sol, 24 hours in that. That is for one complete rotation. We also have a sidereal day, which is 23 hours and 56 minutes, and that accounts for our position, so how we determine day and night here. So there's a little bit of a change which occurs with our sunrise and sunset times. Light year, the distance light travels in a year. That is not a unit of time, but a unit of distance. So light is not occurring instantaneously. It does take time to travel. We have Newton, a unit of force, which will come into play when we deal with rockets. Solar mass, the mass of a sun, our sun in particular. All right, so let's jump right into some practice here and do some conversion. So let's do this first one, 5 light years. So just like we were doing with our metric to English conversions, we're going to set it up railroad track, dimensional analysis style. So we started off with 5 light years. We don't want light years, so for every 1 light year, we want to know how many meters you have. And on the previous page, it should have all of those, so you know where I'm getting these numbers from. All right, so we have 5 light years. We're converting that to meters, so 5 light years times 1.5 times 10 to the 11th meters. The light years should cancel out, and we're left with meters. 7.5 times 10 to the 11th meters. Okay, how about we do parsecs next, number 2. So we have 12 parsecs, and we're going to kilometers. So if you look back, our parsec does not go directly to kilometers. So this is one of those fun 2-step processes. So let's start with our 12 parsecs, just like before. We're going to convert that. So for every 1 parsec, there is 3.0 times 10 to the 16th meters. Now you can either do this 2 separate problems. I'm going to do it as one whole one. We want to get rid of meters, so I'm going to put that in the bottom. So every 1,000 meters, we have 1 kilometer. Now remember, from 1.2 and 1.1, what we're doing, everything on the top is multiplied, and we divide by everything on the bottom. So 12 times 3.08 times 10 to the 16th. And then divided by 1,000. And it should give us 3.69696 times 10 to the 14th. All right, and I'm going to go ahead and jump down to number 4 here. So with number 4, and I'll give you the answer number 3 too while I'm at it. Number 4, it's asking for 5 years. And how many light years is that? Well, light year is a unit of distance, not time. So they are not equal. There's no transferring for it. So if it takes something 5 years, light is also going to take 5 years. Year is time is time. So do not convert. Or if we're dealing with 5 years, light will travel a 5 years worth in a 5-year time period. All right, that concludes 1.4. Hopefully you found that interesting or helpful. Stay tuned when we talk about our next thing, night sky intro, unit 2.